our group will be presenting a topic titled Metallurgy of Iron. So for our group members, we have first Wanu Husina binti Wan Asmadi, Nurfitra binti Zulkifli, Emilia Marisha binti Harun Nizam, Ummu Sulaim binti Josli, and Nur Yasmin Suraya binti Muhammad Fauzi. So the objective of our presentation are to understand what iron is, how is it extract from its ore, and how the metallurgy of iron is applied in real life, and also we will briefly explain the blast furnace process and the different types of iron and steel. For introduction, iron is very important metal that we use almost every day. It is commonly used in buildings, transportation, electrical and electronic device, medical equipment, household items, and many other daily applications. However, iron is not found in its pure form in nature. Instead, it exists as iron ores such as hematite and magnetite. To obtain iron from these ores, the process called metallurgy iron is used. This process takes place in a blast furnace where iron ore, coke, and limestone are added. Coke provides heat and helps remove oxygen from the iron ore, while limestone removes the impurities. As a result, molten iron is produced and collected. Therefore, the metallurgy of iron is essential because it allows raw iron ores to be converted into useful materials that support modern life.
Okay, so next is the applications of metallurgy in industry. We have three applications. First application is the construction industry. Metallurgy plays a vital role in producing strong, durable materials such as steel and iron. Through metallurgical process like alloying and heat treatment, metals are enhanced to improve their strength, hardness, and corrosion resistance. These improved metals are widely used in buildings, bridge, and structural frameworks to ensure safety, stability, and long-term performance. Second is the transportation industry. Metals are important in transportation industry, especially in the manufacturing of vehicles such as cars, trains, and airplanes. Metals like aluminum and steel are processed to achieve high strength-to-weight ratio, which reduce fuel consumption while maintaining safety. Metallurgical technique also improve fatigue resistance, making vehicle more reliable and long-lasting. Last but not least is the electrical and electronics industry. In the electrical and electronic industry, metallurgy is applied to produce metal with high electrical conductivity such as copper and aluminum. These metals are used in electrical wiring, circuit components, and power transmission systems. Metallurgical purifications and processing ensure minimal energy loss and efficient electrical performance. So overall, metallurgy supports industrial development by producing metal with specific properties required for different applications.
Before extraction, iron ore must be prepared. First, dressing and concentration to remove unwanted impurities to increase the iron content. Next, calcination heats the ore without air to remove moisture and carbon dioxide. Then roasting heats the ore in the air to remove volatile impurities and convert sulfates into oxide. After that, sintering fuses fine ore particle into a porous solid that allows air to pass easily in the furnace. Finally, pelletizing forms the ore into a small pellets, improving strength and make it suitable for blast furnace use. Iron extraction from iron ore in a blast furnace using three main materials: iron ore, carbon, and limestone. First, hot air is blown in from the bottom. This makes the coke burn and produce carbon monoxide. Carbon monoxide is important because it removes oxygen from iron ores, changing iron oxide into molten iron. Next, the iron ore contains impurities, mainly silica. To remove this, limestone is added. The limestone breaks down to form calcium oxide, which reacts with silica to form slag, which is calcium silicate. Inside the furnace, Molten iron is heavy, so it sinks to the bottom, and slag is lighter, so it floats on top of the iron. Finally, both are trapped off separately. The molten iron is collected for making steel, and the slag is removed as waste.
The metallurgy of iron is fundamentally governed by the principle of thermodynamics and also chemical kinetics, which are involved oxidation and reduction as reaction, and also the phase transformation. The iron production also explains how the iron is extracted from its ore, how the impurities are managed, and how its properties are engineered. First, the iron production, which is in the theory, iron is being easily oxidized and also tightly bonded to its ore by hematite, and also require strong reducing agent and also high temperature to separate from its oxygen. As for the alloying and also microstructure in physical metallurgy, its alloy, for example steel and also iron cast, depends heavily on their composition and also microstructure. About iron ore is a natural material that contains ions in compound form. Commonly used is hematite with chemical formula of Fe2O3 that chemically bonded with oxygen. So the oxygen that will be removed to form a usable ion, and this process called as a reduction. So it's required very high temperature and also strong reducing agent to produce a molten iron. There are three parts of the material that are used in the blast furnace, which is iron ore, coke, and also limestone. For iron ore, commonly iron is used hematite, which is will produce a molten iron in the bottom of the blast furnace. As for the coke, is a form of carbon that is made from a coal. Basically, it functions as a fuel in the blast furnace, as it will produce a very high temperature, about 1500, to remove the oxygen and then produce the molten iron. As for the limestone, mainly is the calcium carbonate that function or act as a flux to remove impurities and also contamination. And then the reaction will form a slag that is flat on top of the molten iron, so that it can easily remove the oxygen and then form a pure molten iron.
For conclusion, to wrap this up, iron is obtained through a chain of metallurgical method that turn iron or into a metal that can be used. These methods are significant as they yield high quality and sturdy materials in an efficient manner. Iron is still a major factor in today's civilization, especially in the areas of building, moving, and heavy machinery. In general, the metallurgy of iron is the backbone of the industry and a great contributor to the economy.